Welcome to today's lesson in Engineering Science in 3. Today we'll be looking at friction, and the section we'll be looking at is inclined planes, and we'll be focusing on the frictional force. Let's take a look at the question. So the question reads as follows, that we have a block of steel which has a mass of 17 kilograms. A very important keyword is resting on an inclined plane at an angle of 19.5 degrees. Calculate number 1, the frictional force, and number 2, calculate the coefficient of friction. Let's take a look at the solutions. So we're going to look first at the frictional force. So first, let's take a look at the given data. So according to my question, I have a mass of 17 kilograms. The symbol which we use for mass is M. I have the object is at rest, which means the initial velocity is 0. Since the object is at rest, that means there will be no acceleration, because remember, for acceleration we need a change in velocity. It is placed at an angle of 19.5 degrees on an inclined plane, so the plane is at an angle. Calculate the frictional force. So there are forces acting on this object. Okay, so this is my diagram which represents an inclined plane. So you can see that the angle for the inclined plane and the angle for the object is going to be the same. So this is the object, it has a mass. Since the object has a mass, the force of gravity is now acting at an angle, which means the object now has a weight. So since the force of gravity is acting at an angle, that means the object is now going to have two components for the force of gravity, a vertical component and a horizontal component. Okay, if you place an object at rest on the top of an inclined plane, naturally the force of gravity is going to pull the object down. So that now shows that here the object is going to moving down. So it should have had an applied force, but since it's moving, it's at rest. Okay, when it automatically wants to move down, it's going to be the force of gravity, which means here there is no applied force. So since the object is moving down, it means the force of friction is going to move up. The force of friction is always going to move in the opposite direction of the motion. So since the motion is downwards, the frictional force is then going to be moving upwards. Okay, so let's look at how we would calculate this horizontal component. All right, so here is the force of gravity, okay, acting on the object. We said the angle is placed at the top on the vertical. So if I look at the angle, the side directly across this angle is the opposite side, which is my horizontal component. We now have the weight, which is on the hypotenuse side. Since we have opposite and hypotenuse, the trig ratio we are going to use here is sine theta. So sine theta is calculated as opposite over hypotenuse. In this case, the opposite side represents the horizontal component and the hypotenuse represents my weights. So if I do a cross multiplication, the horizontal component is calculated as W sine theta. So make sure you remember that on an inclined plane, the horizontal component of gravity is calculated as W sine theta. So the formula I can now use to calculate the frictional force is your accelerating force is applied minus frictional plus W sine theta. So why do I have different signs? So number one, the object wants to go down, but friction is going up. So these two forces are moving in the opposite direction. Therefore, there is a minus sign. Number two, the object is moving down and the force of gravity, which is my horizontal component, is also moving down. These two forces are moving in the same direction, so the sign is going to be a positive. So when vectors move in the same direction, we add them. When vectors move in the opposite direction, we subtract them. So the object is going down and the horizontal component is going down, there is a plus sign. And remember, we said the horizontal component is W sine theta. Second one, just to recap, the object is going down, but friction is going up. Opposite directions, there is a minus sign. The accelerating force is calculated as mass times acceleration. Since the object is at rest, there is no applied force. The frictional force is what I'm trying to calculate, and weight is calculated as mg. So it's going to be mg sine theta. Let's substitute. My mass is 17. There is no acceleration. It is 0 because it's at rest. The applied force is 0. Friction is what I'm finding. The mass again is 17. Gravity is 9.8 sine. And we now know that the angle for the inclined plane is 90.5. So if the inclined plane is 90.5 degrees, that means the mass is also placed at an angle of 19.5 degrees. These two angles need to be the same. So if I make friction the subject of the formula, if I take friction over onto the other side, friction changes from negative to positive. So our friction is then going to equal to 17 times 9.8 times sine 19.95, and my frictional force is now going to be 55.612 newtons. Next one, let us calculate the coefficient of friction. Okay, so we still have the mass is 17, the object is still at rest, so initial velocity is 0, it's still at rest, there is no acceleration. The angle is 19.95, and now we have one other piece of information. The force of friction is 55.612 newtons. Okay, according to my inclined plane, we now need to know how to calculate this frictional force. Okay, we dealt with the horizontal forces, we're now going to be dealing with the vertical forces. If the weight has a vertical component acting downwards, for the object to stay at rest, all the forces need to be in equilibrium. If I have a vertical force coming down, I need a vertical force acting upwards. This allows the object to stay pressed against the plane. So this vertical force acting upwards to help the object stay at rest is going to be my normal reaction force. So the normal reaction force going upwards equals to the vertical force of weight coming downwards. Okay, let's look at how we will find that. So we now know that the weight is on the hypotenuse side and the vertical force is on the adjacent side. Remember that the angle is still here where it is. So this is the angle, the side next to the angle is what we call the adjacent side. So since I have adjacent and hypotenuse, the side which I'm going to, or the trig ratio which I'm going to use to calculate this vertical component is going to be cos. So cos is made up of the adjacent side and the hypotenuse side. So cos is adjacent over hypotenuse. Okay, my adjacent side is the vertical component and the hypotenuse is the weight. So the vertical component is then calculated as W cos theta. Okay, so on an inclined plane, the vertical component of weight or gravity is calculated as W cos theta. Okay, so the normal reaction force, as I said, is equal to the vertical component, which means on an inclined plane, the normal reaction force is now equal to W cos theta. So the formula which I can use is the coefficient of friction is equal to the frictional force divided by the normal reaction force. In this case, since I'm using an inclined plane, it's going to be the frictional force divided by W cos theta. As we said, the normal reaction force going up is equal to the vertical force coming down for weights, and we said the normal reaction force is equal to W cos theta. So on an inclined plane, the coefficient of friction is going to be the frictional force divided by W cos theta. So we do have the force of friction. Okay, we don't have the weight, so weight is going to be mg. So the force of friction is 55.612. My mass is 17, the gravity is 9.8, and cos the angle is 19.5. So the coefficient of friction is now going to be calculated as 0.354. So the coefficient of friction does not have an SI unit. Since the friction is in newtons and this mg sine theta is a force, is also calculated in newtons, the SI units cancel out. Therefore, my coefficient of friction is simply going to be 0.354. So please remember that the vertical component on an inclined plane is calculated using W cos theta. The normal reaction force going up is equal to the vertical component coming down. Therefore, the normal reaction force is equal to W cos theta. Thank you for watching today's lesson.